polymer is a long molecule which is formed from many smaller molecules joined together. These molecules, the small ones, are called monomers. So a polymer is made of lots of monomers joined together. The polymer is named by putting the prefix poly and then the name of the monomer. For example, ethene monomers will make polyethene polymers. There are two ways to make polymers, and therefore two classes or categories of polymer. These are addition and condensation. Let's look at each of these in turn. Addition polymers are formed from an addition reaction. You can tell from the name you're adding things together. You can recognize an addition reaction because it only forms a single product. One product is formed in an addition reaction. The monomers that can undergo addition reactions and produce addition polymers must contain a carbon-carbon double bond. When you join them together to make the polymer, the double bond breaks and another monomer is added to the end of the chain. Then its double bond breaks and so on. Careful though, the polymer is still named after the monomer, even though it looks like it has changed. So it's not named after what it looks like at the end, it's named after what it looked like when it started. So it's polyethene, not polyethane. To draw the polymer formed from the monomer, turn the double bond into a single bond, like this. Then draw brackets around it, put an N in the bottom right corner to show it is a long chain. You've got to have these bonds sticking out of the brackets. They're called continuation bonds. They show that the molecule is not finished and there's more things on the other side. There's always a mark for putting those in, so make sure you do. To go the other way and turn the polymer back into the monomer, just do the opposite. Remove the brackets, remove the continuation bonds, and then draw in the double bond. You'd be expected to be able to do that both ways. The other way of making polymers is a process called condensation polymerization. This can be recognized because each time a condensation bond is formed, a molecule of water is produced. So there are two products. There's two ways to make a condensation polymer, and they are different in their linkages. The linkage is the collection of atoms and bonds which stick the monomer together, or stick the monomers into the polymer. Let's go through each way of doing that. The first one you should recognize from your organic chemistry. You've got a carboxylic acid group and you've got an alcohol group. But you have a molecule with one either side rather than just one carboxylic acid, one alcohol. So in a condensation polymer like this, you can have monomers that are different. They're not like the addition polymers where they're all the same. Oh, these boxes in the middle, by the way, don't worry about them too much. All they say is that these are different molecules. There could be different things inside of those boxes. They represent just different bits. What really matters for condensation polymerization for the IG is the functional groups. So what we've got here is a dicarboxylic acid. So di means two, so we've got a carboxylic acid on each side. We've also got a dialcohol or a diol with two alcohol groups. You might remember from your organic chemistry part that an alcohol and a carboxylic acid, they react together, they lose a molecule of water. I've color coded it here so you can hopefully see it more clearly where the water comes from, where it goes. They form an ester linkage or an ester bond. This is what that looks like. But because they've got functional groups on either side, on both sides, they then form another one and another one and another one, and they string together to form a polyester. Poly meaning lots, ester meaning ester bonds, so lots of ester bonds. An example of a polyester that you need to know is terylene. That's polyester. The other type of condensation polymer is formed from a carboxylic acid and an amino group. An amino group is a nitrogen and two hydrogens. It reacts like this. Again, I've color-coded it so you can see where the water comes from. And it forms this linkage here called an amide link. You need to memorize and be able to draw and recognize both the ester and the amide link. So this type of condensation polymer is called a polyamide because you've got lots of amide links. An example of a polyamide is the artificial polymer nylon. So if you're asked for an example, say nylon. It's also the type of bond which forms between the amino acids in a protein, for those of you that do biology. Both of these are formed from condensation reactions because they lose a molecule of water. In order to break the bond you can add a molecule of water and then you'll reform the monomers. That's called a hydrolysis reaction. The final type of polymer link that you need to know is the one that holds together carbohydrates, which are a type of polymer. Again, you might know that from biology if you study biology. The monomer for carbohydrates can be represented like this. It undergoes a condensation reaction, like this, losing a molecule of water, and the polymer formed is shown like this. That's carbohydrate. For all of those types of polymer, so all the ones that we've said so far, don't forget to show the condensation, the continuation bonds, sorry I misspoke, the continuation bonds which go off to the side. Alright, thanks for watching.